Um, okay, looks like we've got Bruno and Sebastian listening in. Guys, if either of you want to join the chat, just hit me up in the Slack channel, and I'll invite you to here. So, Jared, how are you doing today?
Oh, I'm doing okay. I'm just knee deep in the hardware configurations.
Do you want to tell folks a little bit about the specifics of what we're looking at?
Yeah, well, specifically looking at purchasing hardware for object storage using SwiftStack. So SwiftStack is a commercialized enterprise distribution of OpenStack Swift, and so they provide some really neat dashboards and features, multi sites, but they make multi-site replication easy. That's going to be kind of an important thing for us if we're going to be trying to do active between availability zones and regions. So that's we weren't sure if we were going to get approval for that this go around, but it looks like we are. So that's pretty exciting.
Yeah. So we talked a little bit about that with the vendor this week, and we initially got an insanely large quote in terms of how much available storage would be available. We let them know that no, we would rather start small and then grow, going forward. Mirantis was able to talk to SwiftStack a little bit about that and get us down into a licensing region that actually made sense for us to roll out in the beginning. So that's really exciting for us to be able to roll out with that capability rather than adding it later. We had looked at using Ceph as an object storage system. The problem there is that the asynchronous replication isn't quite as strong and not bidirectional at all. So the fact that we have that bidirectional async replication with Swift is going to be really powerful in terms of allowing us to build applications that can survive the failure of one of our data centers.
Yeah, and to make matters worse with Ceph's asynchronous replication, the API has nothing built in to prevent you from actually writing to your read-only side. So you can.
Oh, interesting. So it's not even like I had been comparing it to Oracle Data Guard, where you've got this hot warm and you're not able to do anything on the read-only side at all. But you're saying that's not the case with Ceph?
Take it upon yourself to not really screw it up. So that's really kind of less than optimal.
That sounds dangerous. I just got pinged by Daniel. He's asking to join the chat, so I'm going to invite him real quick.
Sure.
There he is. Yeah, that sounds really dangerous. So I'm glad that we're definitely going the Swift route, and when we're able to talk to both sides simultaneously. Daniel, how's it going?
Hey guys.
Yeah, that sounds really dangerous. So I'm glad that we're definitely going the Swift route, and we're able to. Wow, that's a really long delay I'm hearing through Daniel's mic. I'm thinking. Daniel, how's it going?
I'm well.
So I'm glad that we're definitely Swift route, and we're able to. Are you getting this, Jared? This epically long delay?
I'm hearing you barely through Daniel's mic. And what happened to your camera? It shut off again.
My camera?
Yeah.
Oh, interesting. I'm still seeing myself.
Yeah, I just see your icon.
This is interesting. So I actually do a hangout with friends one night a week, and this epically long delay happened to us as well, where only one person out of the entire group of 5 had this like 10-second delay between us saying anything and them hearing it.
That's really weird.
I think I figured it out. I had your YouTube channel still up.
Oh, okay. Yeah, that would do it.
Because I muted this one, I was like, why am I still hearing all that stuff from my feed?
Yeah, I have that problem as well because I'm a tab junkie. I'll end up with Hangouts open, on 4 different workspaces.
I still don't see your camera, but I see a nice little Hi Tim picture.
I'm going to turn my camera off and then back on.
Hey, there you are.
Okay.
I
Rebooting it.
You got a haircut there, didn't you?
I did.
Looking good. So sorry I interrupted you guys. You guys were talking about Ceph and what?
Yeah, so we're talking about we apparently have approval to go forward and purchase storage for Swift and a licensing Swift Stack, the commercial enterprise distro of Swift.
Okay.
Sorry, give me 1 second. Bruno asked to join, so I'm adding him. All right, Bruno, you should have an invite, and lesson learned from Daniel's experience. As you join the chat, just go ahead and close the YouTube channel. Otherwise, things get really weird. Okay, let's see. Any other? The thing that I was typing up for the newsletter just now. We should also mention that the lawyers got together again and worked through the master services agreement. And the amazing thing to me is, I've been in conversations with technical people where non-technical people happen to be sitting nearby, and they kind of get that deer in the headlights look as we talk tech, and they get confused. I actually got to experience that from the other side, listening to the lawyers. It's always interesting listening to experts talk quickly in their own jargon, and they're understanding that everything that each other says, and I'm understanding about half or less of it. But the great thing was they seemed to get along, and they only had a couple of issues with changes that each other had made. And in the end, we have an MSA. If not signed, it's sitting on someone's desk for a signature. So that's a really good sign as well for us to get moving forward very quickly. One other update, we were talking hardware, so we are tentatively also talking about this going into the existing cage in the Ashburn data center, in addition to the hardware footprint that we already have in Allen. To get that object storage capability, we will be adding. How many nodes are we adding in Allen tentatively, Jared?
Well, that's a good question. I think we're going to be adding 3. I think we're going to be adding 3 to Allen and 3 to Ashburn, and we should have a replica going both directions. How much is replicated? Like how many copies is replicated? I think 1, but we need to we'll have to check with Swift Stack on how that's going to be configured. But so we could have. It really depends on how many replicas we set up, but
right.
I'm planning on 3 nodes at the moment. How much money that comes out to, I still don't. We don't know. I don't know how much money we can actually spend on this stuff. So I'm gonna make a reasonable guess and see what happens.
Yeah, and just for those listening, so SwiftNode is basically typically disk constrained. It's not so much memory and CPU constrained as it is disk constrained. So it's a matter of getting a large chassis and just putting a ton of disks in it. I know with Ceph we have SSDs for journaling. Do we have that for Swift as well, or is that a non-issue?
It's for a different purpose. There are SSDs involved, but they're more for like I guess some sort of metadata index so that you can list contents of object directories quickly and things like that. So they're not necessary, but once they get a lot of stuff in there, they become very nice. So we're going to go ahead and start with SSDs already in.
Cool.
Typically, there's in large environments, there are proxy nodes and there are data nodes. They split them out, but in small installations, proxies and data nodes are combined. So I think we're going to have combined, at this point, we're going to go with combined nodes just to keep the node count down.
Right. And since we're talking about object storage, I'll get on one of my favorite soapboxes. So one of the things that really excites me about object storage is the idea that in legacy application deployments, it's really easy to use NFS as a means of distributing files between application and web servers. The problem is, NFS is great until it's not, and when an NFS server dies, it tends to take everything down with it because you need to do a hard reboot to get everything reset. So we can start to use this object storage capability as a way of distributing files between web and application servers in a way that is actually fault tolerant, and you can actually survive issues with the file or the object storage mechanism much more gracefully than you can with an NFS server failure. So, like the way that I would picture that being used, for instance, Java applications where we have, say, 100 application servers that are all deploying the same WAR file, rather than pulling that WAR file from an NFS file share, they could actually pull that WAR file from an object storage system. This is how Elastic Beanstalk works in AWS right now. You can upload a WAR file to S3, and then Elastic Beanstalk will pull from that S3 repository rather than from a file system. And if you're building an application that, say, has a very large catalog of images or PDFs or other data files, rather than distributing that across an NFS file share, you can distribute that into the object storage. It gets automatically replicated to the remote data center, and if we're talking about applications, say a few years from now, that they need to be hybrid enabled, where they're running in a public cloud outside of our data center, they can still use that same object store for the distribution of those data files, rather than having to figure out how to replicate an NFS file server out to a public cloud, which would get really messy really quickly. Bruno, since you're here and application development is kind of your domain, do you have any thoughts on that object storage use case? Is that something that you guys are interested in exploring?
I'm well.
Say that again?
I said I'm well. I have like a 25-minute delay. I'm not sure what's going on. No, I'm just playing. I'm just being silly. Yes, absolutely. We struggle with the NFS mount model, but we've come to rely on it almost exclusively at this point. I would love to get away from that, certainly. And yeah, solutions like object storage like that sound like the way to go. Absolutely. When you say it would be available even to public clouds, are you saying that we would have our file storage in a public cloud, or in our data center somewhere where it's accessible from the outside as well, or what are your thoughts?
So the way that and of course this is something that we need to hammer out officially, but like the way I'm picturing it in my head right now is we have these Swift servers available. They are running inside of our data center. We have a set of them in each data center. But like to get maximum usage out of that object storage platform, we most likely will want to expose the proxy to the public internet as well. So for instance, like a lot of people will use object storage systems to straight up deploy static websites or deploy static images for websites. And to make that actually work, it's going to need to be exposed to the public internet. Now, of course, with that said, you can also have rule sets that limit certain buckets to authenticated access rather than 100% public access. So if you're using a system that has public access through the network available, you can set up authentication and then only allow application servers running in a public platform elsewhere to connect into those buckets and retrieve and set data. That's my vision for it. Jared, is that kind of am I speaking out of turn here?
No, I think. I mean, I think that's probably where the most critical use is. The other use for object storage is going to be for people to potentially use as a backup target for images and volume snapshots, that kind of thing. Things that they want to make available in another region and rely on the replication of Swift to make that available in the other region.
Are you guys looking at making up multiple zones for the data, or I mean, is it going to be all shared in one spot? How are you?
Right now, it's all one. So right now, we're going to have one zone in each region.
Bruno, I apologize. I muted you because I thought an echo was coming through you. I don't think it actually was coming through you, but you should be able to unmute yourself now, too.
Inside, I probably deserved it.
Yeah, so it's going to be basically one global namespace, and that's an interesting kind of topic as well. One thing that is difficult, or not necessarily difficult, but one thing that's something to get used to with object storage is there is no concept of files and directories. Like, it's just paths inside of the object storage system. So you'll see object storage systems that, like, the paths will include slashes, and so your mind initially thinks, oh, that's a directory with files inside of it. But that's just a construct in our mind. That's not actually something that exists in the object storage system. So yeah, all one giant flat namespace. One tenant that's using object storage can't have a bucket name that conflicts with the bucket name of another tenant. And all of that will be worked out through the UI. It won't allow you to create buckets that conflict with each other.
Right, but so how exactly does it control who has access to which bucket, or which files?
So you're the owner of a bucket, and you have access keys that allow you access to that bucket, unless you set the public read-only status of that bucket.
So you will use like whatever your key is for accessing that data, and you'll have to put those keys on the server that needs to get that data.
Right. Yeah, and that'll be integrated in with the Keystone application inside of OpenStack, so that it'll be able to hand out tokens to get access to the files.
When you look at doing this for the portal environment, for all the portals that we have, is there thoughts for looking at how data is utilized? Is there going to be a thing where you say, okay, Kansas paid for 2 terabytes. If they go to 2.1, then something happens. Or is there even a concept of limiting putting a quota on the space that they use?
I know that it's very important to not run out of disk space. That kind of brings everything to a grinding halt. Jared, you were about to say something?
Yeah, there are quotas that will be set.
Okay. Is that quota set per key then, or?
It's set per tenant.
Per tenant?
Yeah.
And a tenant can have multiple keys then?
Actually, I don't know. I think the tenant's going to have a single key, but it may be more granular than that.
Because I was thinking, in the case of if I have a PCI system and a non-PCI system, I don't know how security is going to react to a large data store that it technically has a mix of data on it, but the way that you can get access to that data may be locked down to a key. And if that's a key that I can get from a non-PCI system to access data for a PCI system, that can be an issue.
Well, so for better and worse, like what if we just didn't have PCI systems on the cloud in the first initial release? Like, would that make things easier?
Well, I think that would definitely make things easier, but that question's going to come.
Yeah, it'll definitely come.
I mean, I think of Gov2Go, for example. It's a good app that would do something, or that would fit well within the cloud environment, but there is potential where PCI data could be in it.
Oh, that's interesting. I didn't realize that it would be a PCI application.
Well, it's not by default, but that doesn't mean that somebody can't make it, depending on what they want to do on the other side or on the other end.
True. Yeah. In my mind, I picture us, rolling out this first initial go at the platform without PCI capabilities, just because it is one giant pool of resources, and so you do run into that problem, as we all know, since we're all obviously all of us are done with our PCI training for the year, and none of us are putting that off to the last minute that are on this call right now.
Yeah.
You have till tomorrow, I think, right?
Right.
So with that said, like, no PCI to start out with, and then as we build momentum on the platform, we can start to build subsets of the cloud platform that do allow PCI, and we will keep PCI applications running on hypervisors and storage systems that are dedicated to serving those PCI resources, so that we don't kind of muddy the waters that way. Anybody want to say anything else about object storage? Nothing?
Well, bring up today, we found out that they've signed a deal with AT&T for their fat pipe product. So that should help us with any bandwidth needs that we've got with replication between the regions now. So hopefully we'll be good there.
Yeah, that's basically like we're able to bond the MPLS circuits between the data centers, right?
That's what it sounded like.
Cool. So one other thing that I was going to talk about today, kind of outside of the purview of our cloud specifically, did any of you guys see the article on Netflix's tech blog? What was that? Yesterday? How we build code at Netflix.
No, I didn't.
I will paste a message into the OpenStack Slack channel for folks to get to that. It's kind of interesting on a couple of different levels for me. They talk about and Daniel, I'm going to mute you because I think the echoes might be coming through you. Oh, you're muted. Hey, there we go. Yeah, so now the echo's gone. So on a technical level, they talk through the process of how they build applications for deployment at Netflix, and it involves a very traditional continuous deployment and continuous integration process like we're all familiar with, using a build server like Jenkins to build and test their code. Where it gets interesting to me is that, rather than having a WAR file or some other application archive as the output of that build and test process, they then go ahead and take it further, and they actually bake AMI images with the application built into it, and that whole AMI is their deployment mechanism. So they are doing exclusively blue-green deployments, or as they call it, red-black deployments, where to deploy a new copy of an application, they build a new system image, they start to kind of trickle that out and deploy some systems with that image, and once they've confirmed that those new images are working in production, they start to shut down all of the old ones and replace them with new copies of the application running the new AMI.
So they do that instead of containers?
They do. I think that's probably, and I think they're using some containers. They're starting to look at containers, but you know, further down in maybe in about the middle of the article, they mentioned that they started moving from giant monolithic applications running in their own data center to microservices running in AWS in 2008. So we're 8 years into this process, and you guys might remember that in about the middle of February, they mentioned that in a press release that they are finally shutting down the last of their physical infrastructure. So although they are the leaders and they do amazing things with continuous integration and continuous deployment, and they're all in on cloud, to truly get all in on cloud was an 8-year process for them. I know personally, like, I assumed that they were all cloud years ago, so it was interesting to know that they still had some physical infrastructure running all this time. So containers, I'm sure, will start to happen at Netflix, and because they've done all the hard work of figuring all this stuff out for AMI images, doing the same thing for containers will come more quickly to them than if they were starting from zero. But it's still going to be a multi-year process for them to get to a 100% container-based architecture, I'm sure. All of that to say, basically, sometimes it's easy to feel like we're very far behind, and not just us at NIC, but us, anybody that's not Netflix or Amazon. It's easy to feel like we're light years behind, when in fact, like, we've actually got a pretty good story behind automation, and yeah, we can do a lot better, but we could be doing a lot worse too. So, kind of just a way to say that it's easy to get discouraged, but don't, and we can keep doing pretty awesome stuff. And I don't know, like, a lot of our application deployment pipelines aren't terribly different. It's just that we stop at that application archive rather than going the full blue-green deployment mechanism using containers or virtual machines as the end state. So they really take it seriously. Like, we use Puppet to ensure what's the word? To make sure our deployments are our configuration management is idempotent. They just take that one step further and say, well, we will never make changes to a server. We'll just deploy an all-new server, which is kind of an interesting thing.
And that might be something that we can do before we get to containers on OpenStack. Given how fast we can launch VMs off of Ceph, so that's where Ceph is really going to shine. Is copy on write is just instantaneous VMs. Right. So I know everybody wants to get to containers, but that's it's a pretty close approximation. Really.
Yeah, I mean, so right, not every application necessarily plays very well inside of a container, especially when we're looking at we have a lot of legacy in our environment just because of the fact that we've been around a really long time. So some of our apps are going to be more comfortable in VMs for a while, I'm sure. And yeah, the fact that we can spin up with an API a new VM with copy on write in a matter of seconds or minutes at most really kind of changes the game compared to the manual deployment of virtual machines that we've had to have in the past. VMware is fantastic. We can do a lot of things very quickly with VMware. That API-driven nature of the OpenStack platform will allow us to then do things even an order of magnitude faster than we can do today, I hope. And Bruno, I'll pick on you again as a director of development. Just kind of curious, like, are you able to tell us about your application deployment process? Like what does it look for you guys, and how would you like to make it better?
So I guess you mean, how does it look today? Today is definitely far from what we're talking about here. We have a series of application servers that run on VMs that stay where they are, and we deploy a number of applications per application server, essentially. We have, as far as networking goes, we have a bunch of rules in the F5s to define the applications on the instances that they're running on. And it's all very static and very, baked in. But we're definitely looking at um, what we would like to be able to do is something in the spirit of Wildfly Swarm or Spring Boot, those types of systems where you basically your artifact is now a standalone service that you can fire up anywhere. Um, I'm looking at solutions for um, kind of automatic discovery of which instances those services are running on. Um, we're obviously interested in containers, but we're not there yet. We're not at that stage yet. And I also don't know. I've read conflicting reports about running Java application servers and Java virtual machines in containers. I'm not sure if y'all have any input on that. That'd be fantastic. But there's some discussions around whether that's performant or not. To basically spin up, you know, a bunch of JVMs in a bunch of containers on a given server um, for some values of a bunch at least. Uh, um, but yeah, where we are now is really not very exciting from the perspective of what we're talking about for cloud systems. But we're definitely looking at the future and trying to get away from this. Um, we did have a conversation around the fact that we do have a ton of legacy services, some of which are not very interesting from a revenue or business value standpoint, but they're just there. I'm not sure that we're going to try to go all in on everything, at least not initially for sure. So we may very well keep a legacy environment around for a long time until those services, make more sense to either merge with other services or just go away by themselves. Um, but we do carry a super heavy load of legacy stuff. Yes.
Right, for sure.
We've been
It's interesting.
13 years. Not me here, but the portal has.
Right.
There's all that baggage there.
It's interesting that you mentioned, you use the load balancing capabilities, but those rules are kind of static. That's actually kind of a bit of a relief to hear. We've been looking at the load balancing as a service inside of OpenStack, and we're looking at deploying the load balancing as a service version 2, which provides a lot of technical improvements over the version 1 API inside of OpenStack. The negative being there's no user interface for it yet. So all of your communication with that version 2 load balancer API has to happen through the API rather than through the Horizon GUI that's built inside of the OpenStack administrative interface. So knowing that we at least have one portal that's not doing a lot of tweaking of load balancer rules, that's kind of a relief to hear.
Well, that's one positive about that. That's good.
Right.
So I'll be bugging you instead of the F5 people, I guess, at ETS in that case.
Or we'll teach you to use the API.
Yeah.
We're gonna do some training
Well,
on that.
hopefully, the whole point of the API, and that's pretty obvious, I guess, but is that we'll be able to bake that into the deployment, scenario where it'll do it itself.
Yeah.
And we won't have to worry about a thing. But yeah,
Right.
we're very far from blue-green deployment as you described earlier. That would be ideal to allow us to iterate a lot faster.
Yeah, I mean it's a big problem. Like the biggest problem, putting on my application developer hat and thinking through deployments of years past, like always the biggest problem that we run into that would keep us from doing a blue-green deployment is the fact that we have these databases behind all of our applications. And a lot of times deploying a new version of an application also involves deploying schema changes to the database behind that app. And there are ways to write applications such that they can work with a database revision plus or minus their current version, but that also takes a lot of time and testing to do that. And until we develop a process for doing that gracefully, we're not really able to do a blue-green deployment because every application will expect a very specific version of the database schema behind it. and if that specific version doesn't exist, things just won't work. So that's a very big thing to think through before we can say that our applications are like absolutely blue-green cloud ready. Daniel, before I ask that question to Bruno, it looked like you had something to say.
I was going to say that a lot of the things right now, most of the apps that portals and even us deploy are pretty heavy. And so, I mean, they've got a lot of features that are really rolled into what that application is doing. And when you start looking at stuff being done with like containers and things like that, they usually get a little bit more lightweight, and they're very focused on what they do. I mean, you're looking at trying to do things as a microservice more that way, or at least a limited number of services. And then also to Bruno's point on the load balancing thing, that's actually something that you can do now that would actually help you later, is setting up your application, basically setting up your own application health page. Within your app, you need something that says, my application is running green or red, or even a yellow for warning, or whichever way you want to do it. And that same page could then be used by whatever your load balancer test is to determine, okay, my application is good, my application is bad. And you can even set a trigger in your application itself, either look for a file in the system that says, hey, go into sleep mode or whatever, and that application will essentially keep working, but it will communicate to the load balancer that, hey, I'm going offline, don't give me new traffic. And that's really something that you can even do now with the F5s. And I know James Dimitrov was trying to look at what they can start doing for TPE to do that. But going forward, even from the website, you really want to look at something like that where you provide the load balancer, here's the health of my application. And when people are looking at those microservices, even there's part of the microservice where there's a health status check that they set up to say, yes, I'm good, no, I'm not. Either I can't talk to the database, so I'm not doing good, whatever. You build that into the application. Once that's there, then you have the ability where you don't even have to tell networking that you're doing something to the app. The app will tell the load balancer, I'm good or I'm bad.
Definitely.
Yeah, that reduces a lot of complexity in load balancer health checks, because that's sometimes pretty hard to write that in at the load balancer layer,
Yeah, when we first rolled out F5s, we went that route of doing all of the complex health checking inside of the F5, and we were able to write basically, like, it was easy to do because it was just a matter of writing a Perl script that ran on the F5. We didn't have to touch any applications ever. Until you get so many Perl scripts running on the F5 that you're burning through a ton of CPU on your F5. It's a lot easier for the F5 to make a simple HTTP call rather than running a Perl script to determine whether or not a virtual server should be marked up or down.
Yeah, so one of the things that we did, so previous life at Garmin, one of their application page, we've got a developer who made a heavy monitoring page and a light monitoring page. The heavy monitoring page, I mean, it gave like a list of everything. Here's the status of the database. Here's the service calls for all of our mounts. I mean, it just listed a ton of stuff. And that was really helpful for people who are trying to diagnose problems. They could go and look at that. It would actually say, here's what my peer is doing. It says it's good or not. But for the F5, they just had a simple page that said good, critical, or warning. And a warning just meant that the F5 would keep it in the pool, but alerts would be generated from the monitoring system. And if it ever said critical, that just meant, okay, this node goes out of the pool. Because of how the F5 works, it would still get traffic until that traffic, until what the target released trying to talk to that server. But that made all the difference in their deployment methods because they could control what that page did. And it also helped the people on the ops side because they knew, hey, if this site is showing a problem, even in the F5 or in monitoring, they could go see this page and they could see specifically from that page, this Tomcat server is not seeing its WAR file, or this Tomcat server can't talk to its database.
Yeah, and you mentioned that concept of the soft off, basically. I think that, like, for instance, in TPE, we have a ping method that you can call to determine whether or not TPE is able to talk to its database and blah, blah, blah. But the fact that it's not, we're not able to toggle that manually to say, yes, allow traffic, no, pretend like this server's going down. That means that, like, we're not 100% there, but we're probably about 80% of the way there to allowing the application to deal with telling the F5 its health automatically.
Yeah, that's very useful, Daniel and Kim. I had a conversation recently with Brent Myers, who does a lot of our LTM rules and maintenance and that sort of thing, because I actually didn't know exactly how these checks were done for us. They're actually, for the most part, they're very, very basic at this point. Essentially just checking that the service runs on a given port and responds in some kind of way. But there wasn't any of that, more in-depth status checking. So we've actually talked about that. I hadn't thought about two versions of the page. That's actually a really good idea. So I'm gonna steal that and talk about that with the team. But yeah, those are super useful going forward, regardless of whether you're right, regardless of whether we're in the OpenStack environment or not.
Yeah, we got bit by that when we first rolled the load balancers out. Like, the default check was just a TCP check. So if the service was listening on a port, it was green. Well, the web server may not actually be responding correctly, or even if the web server is working, maybe it can't make a database connection. So you end up in a green status despite the application not being green at all.
Yeah, and one of the things.
Sorry, go ahead.
So I was going to say, one of the things with the doing the heavy and the light, the heavy was one of those things that we actually logged. The light, we basically put in an ignore, because in that case we had, like, the F5, since it was such a simple check, the F5 tested every 5 seconds, I believe, in most cases, to see if that page was there. So they knew, for however long that, it was every 5 seconds. We ignored it out of the logs. I think it showed up on the system logs, but when it went to our syslog servers, it was dropped out of there entirely. We left the heavy in there because that told us from the alerting side that the monitoring environment could still see that heavy page, and that heavy page was used as a secondary check to say, okay, well, the light page isn't working, or something's not happening there, it's giving bad, or it's not showing up, and the secondary heavy page was used to partially provide all that information, but also led for more in-depth checks for the alerting system itself to throw errors or throw something from the alert log.
So on the live page, you'd have to keep that pretty fast, right? Since we're checking very frequently. So what kind of critical things would you monitor for the warning state?
In that case, with the essentially they went from the app perspective. So if this application had a series of WAR files, if it had a series of external files, text files or anything like that, if it couldn't talk to an NFS share, if that was part of it, if it couldn't talk to a database, it also had a couple of database checks. It had one for if the database could be talked to, but it also did metrics type checks to say, do I have too many connections to my database, or am I getting high on that? So I mean, they threw in more as they ran into things of, these are things that my app really needs to know about its resources. So it led to a lot of things where those applications could help monitor the other systems, because in some of those cases where they'd have like a cluster, it would be able to tell you the health page of the sister, and that was actually helpful because we ran into some events where the F5 couldn't talk to other servers, but all the stack was up. And that really helped quick when we went to the health page and said, well, node 5 says 4, 5, and 6 are all up. Only the F5 is saying they're down. So, there was a lot of computation that went on that heavy, which is why I think it was only checked like every 5 minutes, depending on, and that kind of depends on need. But it definitely helped when you started throwing in there anything that just think about it, anything from your app perspective. What does that app need to run? Those are things that you want to check and make sure are there. If it has to, make sure, even something as stupid as, I need this disk on the file system to not be full or not to be over 80%. Like if you have like an FTP service or something like that, or a file gathering service, the moment you hit 80%, you might need to tell, hey, I need other nodes to take this traffic, not because I can't handle the load, but because I'm running out of disk space.
Makes a lot of sense.
So yeah, I remember the devs, they played a little game of I'm an app, and everybody else got to ask questions of the person who's an app today, and that person who is an app tries to answer the questions, and those were the things that they would take to figure out, oh, okay, this is something I need to check when I'm going through and doing these kind of things.
That's pretty cool. That was a really good discussion, guys. Do you guys have anything else you want to talk about in terms of app deployments or shift to any other topics at all?
This is all going in the Virginia data center, right?
The new stuff is planned to, yes. So we'll be adding a couple of nodes in Allen to add that object storage capability, but the second region, yes, we're looking at Ashburn.
So what does it look like if we move out of Ashburn?
Probably looks like we built another region or availability zone in the other data center, and let people migrate, or they stay there in Ashburn forever.
Okay.
Until the heat death of the universe.
Get buried. At some point, Papa Nick's going to stop paying the bill.
Right.
So I guess that's the heat death of the universe.
I think it's not optimal that we're going in Ashburn, just because of the way the wind is blowing on that. But we have not been given any relief on our implementation deadlines, so Ashburn it is.
Okay.
And so like hypothetically, like we're going to be making a big push for people to deploy their applications in a cloud-friendly way, using configuration management, not tying things to Snowflake virtual machines. So ideally, when a third region comes online, it'll be a piece of cake to deploy in that third region after you've already deployed in your first and second region. Will we be able to force people to deploy apps that way? No. And that's where we might get into applications that, survive until the heat death of the universe. But, man, I sure hope that we do things a better way.
You can only lead the horse to water, right?
Right, exactly.
Did you just call me a horse?
No, I would never call you a horse.
We're on board with the principle that is that we have, and y'all too, we have to deal with a lot of, like I said, a lot of legacy stuff that, there's just so much work to do to bring everything into this that, we're going to have to make choices. It's really the only thing.
Yeah, I mean, for sure. So, back to that Netflix thing where they started their move to the cloud in 2008, and it's 2016, and they're finally shutting down their physical data center. We could improve the financials application deployments by orders of magnitude beyond what we've already done. But I still remember when we did literally all deployments and configuration by hand, and I feel really good about where we are today, even though I know that we can get orders of magnitude better. And it's easy for ETS to do that because there are so few applications under the purview of ETS to do. It's a totally different ball of wax for you guys at the portals because you are dealing with so many different services that have grown throughout the years, for sure.
Well, if we can get to where we're doing, the blue-green style deployments where we just fire up a brand new virtual machine that will, that has the application installed on it, like what Netflix is doing. You can kind of be bad at configuration management and and have that work, because
True.
you've baked it into your image and you're ready to go, at any time. So I think we could. I think we're a lot further along than we might think we are.
But I
Definitely.
wouldn't, Jared, I also wouldn't want to give you like 250 different image templates, for each one of my services,
Yeah.
each one being poorly configured, and then have you try to, juggle with that. Um, so I'd much rather do some work ahead of time, especially if we're doing this push for better architecture, if you want to call it that. But I get what you're saying though. It's possible to sort of kind of port what we have there, with limited impact. But I would much prefer not.
Yeah, I mean, just getting those deployment processes like out of people's brains and into shell scripts is a great 75% solution. So that's actually all I had to talk about this week, guys. I really appreciate you joining. Do you guys have any other parting shots before we close up for the week?
Other than I would hope that all portals start building in those health pages. Makes life a lot easier for a lot of things.
I could definitely see a cross-portal kind of working group to make sure that we at least kind of go in the same general direction on those health pages. That way we don't end up with 30-some health check definitions inside of the F5.
Right.
That would definitely be an interesting thing to bring up on the DoD list. I'll add that into the cloud newsletter this week just to see if other folks are interested in working on it.
Right.
All right. Well, thanks a lot, everybody.
Later.
See you next week.